Hello, hello. This is Grace. It is June 29th, 2018. This is the first recording that I'm doing of, I guess you could call my development notes. So I am working on a problem right now on Assemble and trying to brainstorm my way through it. And I started to write some of my thoughts down just to parse them a bit better. But I think it might be easier for me to talk some of them out. So here we are. So what we're looking at is a way to connect data to a user interface. And the goals of this are to make it as flexible as possible and understandable, kind of intuitive for end users to grasp. So, and as this note says, it's been a big problem. It's difficult to kind of capture let me say that every single app uses data differently and models its data differently. We want to create a system that is generic enough that it can be used for many different situations, many different apps, and it's, I guess, we can't build the data layer. We can't tackle this data problem in the way that you would normally tackle the data problem in typical apps that you build. In typical apps that you build, you figure out, okay, what do I need this one app to do? And then you type out what all of the data should look like that you need in order to solve that problem. And when you're done, you have a data situation that works perfectly for that one app and is useless in any other context. So, we need a completely different process because we need to create a data layer here that we can just pick up, move to a different app, and it just works flawlessly and solves 100 different problems at the same time. You can build 100 different apps without changing the code. This will be fun. All right. So let me. So I have a few new leads on this, which is very exciting. The first thing that I saw a couple days ago was a project called MobX, and kind of one of the things that I've been saying all along with Assemble, an analogy that I'm drawing is that, let me hide this for a minute, is that the most successful programming model, the most successful programming environment in the world is the humble spreadsheet. It is powerful. You can do a million different things with a spreadsheet. It's accessible, so anyone with an afternoon to sit down and spend cranking away on a spreadsheet can understand the fundamental workings of a spreadsheet and can be pretty productive with it by the end of the afternoon. So there are a number of reasons that I think I could attribute the success of the spreadsheet to. One is you don't really need all that much code. All the code that you write is kind of constrained into simple formulas, and formulas are, easy to look up, if nothing else. I don't really like the formulas that are there, but they're easy for people to understand and use. So, so simple formulas, and I think one of the big things is you can see all of your data on the sheet. There is nothing in a spreadsheet that is behind the scenes, unless you deliberately hide cells or push things behind the scenes. So I think the kind of almost the visual nature of being able to see how everything ties together, or if you see a number on the spreadsheet and want to know where it came from, you can investigate the relationships between all of your data. So, that was a big tangent. I'm sorry about that. Let's get back to the... Oh, right. So, I've been trying to figure out a way to bring kind of the spreadsheet model of storing and manipulating data into the app world. And so this library called MobX caught my eye when they said, let's see, introduction, somewhere in here. It says using this library essentially is like turning a property of an object into a spreadsheet cell. This is something that they call out a number of times throughout the documentation for MobX, is spreadsheet programs. Computations like these resemble formulas in spreadsheet programs like Microsoft Excel. MobX is inspired by reactive programming principles as found in spreadsheets. So that really stood out to me when I first saw the library, because I've been trying to figure out what is it about spreadsheets that works so well. And looking into this library MobX, it seems like it's a huge, just tremendous achievement. Looking through this, it seems like it has the potential to really simplify a lot of the complicated issues that we're looking at. I'm not quite sure how it'll fit in, but I think that if we hammer away at the problem and just try to fit MobX into some of the apps that we've already built, we'll start to see trends emerge. We'll start to see common patterns of essentially ways that we can construct general use cases or construct general patterns that intuitively click with people, with end users, without requiring a lot of explanation. So, wow, that was a lot. All right, so MobX, that's the first piece of the puzzle that I think we'll be looking at. Second piece, yes, the author of MobX. I believe he's the original author. I should check that. Okay, at least the primary author. Michael Weststraat from the Netherlands. He has a number of awesome blog posts that take this library MobX and break it down into just very great and illuminating explanations of how it works. And so I think they're all posted on Hacker Noon's Medium collection. Fundamental Principles Behind MobX is excellent reading. Becoming Fully Reactive, in-depth explanation of MobX, excellent reading. And this one here doesn't go into the workings of the library so much, how to decouple state and UI. It's more of an example of a way of programming an app that MobX makes possible, which I think is a really clean way to write an app that we'll see, it might be flexible enough to do some really cool things with. So basically he's advocating in this blog post for kind of for people to keep all of their data that powers an application in a single store, a data store. And this is a common idea that all of the data that kind of determines the workings of an application or the current state of an application should be contained in one place. Let me work this out a little bit more. Okay. I'm not sure we should get too much into the details of this blog post. If you're interested, it's well worth a read, but be prepared to get out pencil and paper or your favorite text editor and take notes, because it is it's involved, we'll say. I've pulled out kind of what I think is relevant for us into this text editor. Basically, the things that caught my eye out of that article were key pieces of an application that I think everyone can understand. The first piece of an application that we need to handle, that we need to figure out what to do with, is an action. And an action could be anything from you load the page, you click on a link, you hit submit on a form field. An action can be anything that you, the user of an app, does to interact with the app. I'm actually going to stop using the term app so much and start using the term software, because I think app has certain connotations that, or not connotations, app has certain implications that I think will be challenging later. And I think software in general is a more broad term than app, and I think it offers more possibilities than merely thinking about apps as the basic unit of code or of software. Okay. That's pedantic. Forgive me. So we have a user action. It's anything that a user does to interact with software. In this case, the user is doing something to change the current page, I guess, of an application. Michael calls it the current view. I've modified this code block a little bit from the example that he gave in his blog post. And one of the important things that I've done in here is add this line. So I'm gonna gloss over it for right now. But in his code example, it was something like this: the current view of the application, the current page that we're on, might be a blog post. So anytime the user takes some action, this could be an action visit blog post page. There could be an action for visit about page. There could be an action for sign in. Let me really quickly make sure we don't lose this. Okay, and so this would look like let's see. So these two actions are telling the app that the user wants to visit certain pages of the app, whether the blog page or the about page. This sign-in page, I guess this is a little bit of a more complicated action because we need to process the username and password that the user has given us, presumably. So we'll do something like when the user signs in, we will say the current view is, we'll go back to the home page. We might also set something like the current user. Something like params here, short for parameters. It could be something like username is foo, password is bar. So, okay, so we have something like this. So when the current user, when the server responds back, saying the current user that's valid sign-in information or not, then this current user property will figure out this will update automatically with the I guess ID or username or what have you of the current user. So this could in MobX land, this wait for server response function has a name and is called from promise. So we'll just substitute that in. And let's see. This is actually interesting as well. Okay, I don't want to get too involved with this, so we'll say that's fine. That's kind of the gist of how Michael is using this pattern in his blog post, and I really like it. It's a little bit of work to define everything. You're kind of being, I mean, not too verbose about things. You are storing the current, like, the view of the application in the state. It's being very explicit about tracking everything that you need to know about the app in the state, which there are massive benefits to. So, I mean, the drawbacks aren't really worth going into because they're kind of trivial compared to the advantages that it gets you. All right, sweeping a lot of things under the carpet there. So I want to take it a step further. Where here, I guess Michael is taking the blog, or taking the different user actions, and he wants the app to navigate to different pages based on the actions that the user takes. Alright, that's easy enough. He just says what page the user should navigate to based on just putting the name of the page right in the state here, which is, I don't like that too much, because down here, just remember this, the current view is something like blog. All right. All right, let me go back to the blog post. Alright, so we're looking for this section, to the DOM. In this section, he's talking about how to put things on the web page, how to render things like buttons or text or what have you. And typically, he's using React like we are, so the way that you do this is with a React component. And the key piece of this section is a function called renderCurrentView, which gets passed in the store. So this function that he has, this, I guess, a component, or no, just a function that he has is I suppose this would be a component. Doesn't really matter. Anyway, it's the purpose of this is simply to look at the view name, the name of the view. In our example, it would be looking at this page's blog, or page's about, page's home, and it's looking at the name of the view, and it's listing out if the view is overview, then return this this React component, which essentially would render the document overview page. If the name of the page is document, return the document component. And as an application grows, essentially you would need to keep adding this code here to this function every single time you want a new page, or every single time you essentially you specify that the app should display something new on the screen. You would be you'd need to specify that somehow in here. So maybe about people Matt. This would need another case in here. Case about people Matt would, maybe it renders the Okay, I don't want to tackle nested routes like that yet. Let's keep it relatively simple. Basically, this pattern here is called string typing, where you have an overview, right? You say, I want to display the overview page. So what do? Up here, can I link to this? Down here, you say, you type out the word overview in your code, and you say, when the view's name is overview, do this thing. And in order for that code to run, you're depending on some code in another place, way over here. You type in the word overview in your code again. And you're depending on those two to just match up. And when both things are equal to overview, then this code executes. And to me, that seems like hidden logic. It's leads to code that's just difficult to maintain, that you need any programmer or anyone who wants to work with this app or make modifications to this app needs to know that this page that we're looking at is called the overview page. And if you ever want to get to that page, to some extent, you need to type in the word overview in the code, or you need to reference this label for the page. So that in my opinion doesn't scale. It just The word for that is called string typing, where we're using a string, this bit of text, to represent a value, to represent, I guess, the programmer's intent. The programmer's intent in this case is that when the user wants to show the overview page, the intent is that the current view is the overview page. Now, that's not what this code is saying. If you read it explicitly, this code never says the thing that we should display next is the overview page. The code is saying the name of the thing that we should display next is overview. It's up to other code somewhere else in the document to say, if the name of the thing that we're trying to display is overview, then display the overview component. So I want to get rid of that string typing. I don't want to use a string or labels to represent what different parts of the application are. That just doesn't scale. That'll lead to bugs. That'll just be annoying to work with. So let's look at an alternative. And this alternative is something I'm really excited about. It's essentially, I think that we'll be able to use, there's a way to actually say up here in the action, instead of saying render, we want to show a page called about, I think we'll be able to say something like, this is just, I'm going to put in the actual code for it, but something like this, where this code actually goes out and finds the about page. And this about page doesn't need to live in our app. It can be something like a bit source component. So it can be something that like the user or that the application developer hasn't even written. It can just be a sign-in page, let's say. Maybe this isn't a good example. I don't know. Okay. Well, it can be it's, I guess, an address. Rather than a label that's a name, this will point us, import, will point us, it gives us an address and says, if you go to this aboutpage.js file, wherever that lives, and you pull it into this application, this will behave exactly like we typed in the component directly. So we don't need to worry about the name of the thing being overview. We just find the thing that we want to render when the person visits the about page. We directly tie the address of the thing into this action. And then later we don't need the kind of case-by-case logic. It will end up with something more like this line right here. So we don't return different objects for different view names. We simply return the view component's value. All right. Wow, that was a lot of explanation for not much of a payoff right there. I don't have a demo or anything to show for it, which is unfortunate, but at least it's clearer in my head of what the value is. I guess there are a few open questions I still have about this. Oh. Which is that the one concern that you might be raising is that up here we wrote a string called blog, which we called string typing and said was a bad thing. And down here we write a string called about page, and how is that not string typing as well? The main thing about this is that we don't need this to be hard-coded. We can say the component name is aboutpage.js, which would be hard-coding it, but we can also just as easily say pull this from the user params. Which this could this can be defined at runtime, essentially. We don't need to hard code any values here. All right. I'm gonna work on this a bit. Like I said, I'm not sure the value that this gives us. I think it does give us value, but it's hard to parse out where that where the advantages are. So I'm going to need to spend a bit more time with it. Okay. I'm wondering if there's anything else that I wanted to go over. Before I close this off. I think what will likely end up happening is that we'll need one store for shared data and one store that deals only with client-side data. And that client-side data specifically meaning data pertaining to one user on one device. Or I guess just one device. I don't want to be what's the word? I'm going to go with dictatorial about how devices and users are related in a piece of software. There could be a device that is open for anyone to use, and there could be a device tied to a single user. There could be a device meant for use by two people at the same time, which would be strange, but it could happen. So I don't want to put constraints on this as much as possible, but I do think that there is inherently kind of or there may be a need to separate data that is only needed to display the software on the device versus data that needs to be shared between multiple people. So that might be a distinction that we make. And that would, I suppose, play nicely with privacy settings. Anything in one bucket could be considered private data, and anything in the other bucket could be considered public. I'll have to think about that. The other, just to get all my thoughts out, the other consideration with public versus private buckets, in the public bucket, user does something in the app, maybe enters data in, and we want that data to be available to multiple people. It's not particular to this one user. It should be available to everyone. So in that case, we need to kind of send the data over the network. We need to watch for data. We need the application to know when data is entered that should be shared with other people, and to make that data available to all other users of the app in a consistent way. Think about Google Spreadsheet, Google Sheets, I guess it's called, where one person does something, everybody else sees the result, as if they're looking at the same document. So we'll need something of that in that vein. That'll be tricky on its own. I'm looking forward to that, actually. Okay. Anything else? In order to make that happen, probably we will want to just use something like the just MobX reactions. MobX reactions are observe kind of all the data in an application that you care about, and when something changes, it takes an action. That action, in this case, would likely be sending the data to a shared system, just a public or semi-public database, however you want to call it. And at the same time as that happens, we would need, or immediately after we publish that data to the shared data system, we would need to notify any other devices connected to the application that this shared data model has been updated. Those different devices would need to pull the new data. And that is where things get interesting, possibly messy. There can be a race condition if two people update the same value at the same time. We would need some kind of resolution mechanism, some kind of... I mean, we could go off of timestamps to say whoever started editing the thing first, but... Oh. I'm wondering if it'll be generic enough is the only thing. And the only way to get a solid answer on that is to just take the two demo applications that we have and just start applying this to them and see how close we can get the code. Ideally, we would be able to write the same snippet of code, run it in both applications, and even though the data powering each of those applications is different, we'd be able to power both of them. Ideally, this same code that ties data into the UI is flexible enough to support both apps. I don't know if we're going to get there with this sprint, and a very, I think a much more plausible thing to shoot for would be I think a much more plausible thing to shoot for than identical code powering both apps would be to to retain a small piece of code in each apps that's different. And that small piece of code could just specify, like, at a high level what the data should look like. And behind the scenes, both apps are relying on shared code that is, I guess, 90% the same, and just the top 10% of the iceberg is where we specify what the differences should be. And I think that's possible, and I think that's a good first step. And we're not going to be able to perfect codeless software on the first sprint, but I think just slowly paring away at the code that is required, I think we'll be able to get there before long. So those are my thoughts. It's a lot. Hopefully something comes out of it. All right. Anyway, until next time.